Hello, my name is Emily Melo, and today our group, the Three Musketeers, is going to be talking about the history of Robert Hooke. So, on the agenda, first I will cover the early life and foundations of Robert Hooke, as well as Hooke's Law. Then Ryan will be talking about the conflict between Isaac Newton and Robert Hooke, as well as the modern impact of Hooke's work. And lastly, Dylan will cover the discoveries, inventions, and accomplishments of Robert Hooke. So let's get into it. Our main idea is that from his curious early life to his conflict with Newton, Robert Hooke shaped principles that still impact modern physics, and his many other discoveries continue to show how influential he was across science. So, he was born on July 18th in 1635 at the village of Freshwater on the Isle of Wight. He was a very curious child, making sundials, clocks from scrap parts, and even a toy boat that can shoot cannons. He got his education at home by his father until the age of 13, where he entered Westminster School. During that time, he also served an apprenticeship as an artist and then later attended Oxford University. Here, Hooke impressed many scientists with his skills of designing experiments and also building equipment. This quickly earned him a spot as the assistant for chemist Robert Boyle, who most of us know discovered the inverse relationship between pressure and the volume of a gas at a constant temperature. More of this can be found in the Encyclopedia of Forensic Scientists, published in 2008 by Dr. Suzanne Bell. In 1662, Robert Hooke was named the curator of experiments of the newly formed Royal Society of London. This meant that he was responsible for demonstrating new experiments at the Society's weekly meetings. He ended up becoming a professor of geometry at Gresham College in London, where he was given a room to stay that he would stay until his death. This was found by the University of California Museum of Paleontology. Moving into Hooke's law, he discovered this law in the 1660s while experimenting with springs, wires, wood, and even air as he tried to design a more accurate portable clock. By carefully adding weights and measuring how each material stretched, he noticed that there was a consistent pattern. The deformation of the spring was proportional to the applied force, as long as the material wasn't overstretched. He later published this in 1678, saying something as simple as, quote, "as the extension, so the force," end quote, which became the modern law as F equals Kx, where F is the force, X is the extension, and K is the spring constant. And we come to learn that a larger K value means a stiffer spring, found by Khan Academy. To show how we can find the spring constant, imagine a simple experiment where we hang different masses from a spring and measure how far it stretches each time. For example, I've added in some data as well as a graph. Here we can see when we add 0.1 kilograms, the force is 0.98 newtons, and the spring extends by 0.02 meters. Increasing the mass increases the force, and each time the extension increases proportionally. When we use these values we found and substitute them into Hooke's law equation for each trial, we get the same value of about 49 newtons per meter. This consistent ratio tells us the spring obeys Hooke's law, and that the 49 newtons per meter is the spring constant. In class during our lab, we use grams instead of kilograms, but that can be converted and then multiplied by gravity to find force. And we also used centimeters, which can be converted to meters. This is because, in the end, we want units in newtons, which is kilograms times meter per second squared, over meters. Now that we know about Hooke's life and Hooke's law specifically, I'm going to hand it to Ryan, who's going to talk about how Hooke's personality may have led to some conflicts.
How's it going, guys? My name's Ryan. This is my first slide. Thank you, Emily. So my section is about the rivalry between Robert Hooke and Isaac Newton. It's a super historic rivalry that goes way more in depth than we might have thought. Lots of drama between these two scientists. So a lot of this background comes from Micrographia by Hooke and some of Newton's biographies, like the one by Westphal. The tension really kicked off after Robert Hooke published Micrographia in 1665, where he pushed his wave theory of light. Newton came in later with his prism experiments and introduced his particle theory, and Robert Hooke basically accused him of taking his ideas without any credit. This bothered Newton. Newton did not handle any criticism well whatsoever, so he just became super private and stopped sharing his work for a very, very long time. This started a long and messy feud between these two high-profile scientists. My next slide is kind of why their conflict grew and why they clashed. So a lot of this next part comes from historians like Lisa Jardine and Stephen Chaplin, who talk about their personalities a lot. Huck and Newton clashed mostly because they were complete opposites in how they worked. Huck was all about the hands on experiments, building things, testing things, and he was the curator of experiments at the Royal Society. Newton was more of a quiet, mathematical, let me work alone type of scientist. There was also some power and ego involved. Robert Hooke had more status early on, but after Hooke died, Newton became president of the Royal Society, and that's when Hooke's portrait mysteriously disappeared. So this rival wasn't just scientific, it was also personal and political too. Robert Hooke really thought that they just took down his portrait. Slide 3 is my last slide. This is about Hooke's modern impact and how he's still making an impact today. So a lot of Hooke's impact today comes from Britannica highlights, especially Hooke's law, which we talked about in class. Hooke's law, the one relating force and how much a spring stretches, is still used everywhere in engineering to this day, and material science as well uses that. He also improved clock accuracy with the balance spring. Hooke even suggested an early on version of the inverse square law that Newton later used when formatting his theory of gravity, which he didn't give Robert Hooke any credit for. And he did work with pendulums and planetary motion to try to model orbits. So even though Hooke doesn't always get as much credit as he deserves, his ideas will still show up in modern physics all the time. All right, I'm going to pass it on to Dylan.
Hello, my name is Dylan, and we will be talking about Hooke's other discoveries, not just with the Hooke's law. One of Hooke's biggest scientific achievements is the discovery of the modern microscope. The way he improved the microscope is by placing 3 mirrors to magnify the images and add a light for better viewing. With this intricate structure, he was able to emerge different living things in detail under the powerful microscope. Not only he was a part of these discoveries, but he also wrote an illustrated book called Microphagia, which presented his findings such as crystals, salts, minerals, fungi, plants, and animals, and among other living things. Hooke also coined the term cell as the smallest component of living organisms. Hello, this will be my next slide. It's called Hooke's Inventions. Um, Other inventions that he was accredited with, which included a compound microscope, the wheel barometer, and the hydrometer. The wheel barometer is used to measure the air pressure in the air. Hooke's version of the wheel barometer consisted of a curved tube filled with mercury and a ball that floats on top. When the air pressure is increased, the increased weight pushing down on the mercury forces more mercury in the tube, causing the ball to move upwards. Hooke's version of the hydrometer is used to measure the humidity in the air. Down below, we have pictures of his inventions, which is a compound microscope, the wheel barometer, and a hydrometer. This is my last slide, and we're going to be talking about other things that Hooke accomplished. This was once an invention or discovery of Hooke, but however, I still believe this was important in his life. Was after the Great Fires that happened in London, which burned most of the city down. He was very influential, and he really helped rebuild London after the fires. He was very big a part of the architecture in London and rebuilding it. He was known for the Flamstead House and the monument, and I believe this to be important because it shows that he wasn't just known for the Hooke law or the other inventions such as the microscope or the wheel barometer like we talked about before. He also was very big in architecture as well. I will be passing this on to Emily now. Thank you.
Thank you, Dylan. So, to conclude, I talked about Hooke's early life and foundations, as well as Hooke's law. Ryan talked about the conflict between Isaac Newton and Robert Hooke, as well as the modern impact of Hooke's work. And Dylan talked about the discoveries, inventions, and accomplishments of Hooke. Here is our bibliography with all the references we used throughout this presentation. Lastly, we just wanted to say thank you for an amazing semester, and we hope that you learned that from a curious childhood to certain conflicts he had, that Robert Hooke made discoveries that still shape modern science today.